Hello everybody. Some people maybe already saw me a couple of weeks ago on the Ceph meetup in Rijswijk near to Den Haag. So probably you will, those who were there, who will see the same slides that I've done there. So I apologize for that, but for the people who doesn't see them, I would really like to go through them.
How many were in the...
How many were there in Rijswijk? Okay, good. So you can check if I talked the truth a couple of weeks ago. Okay, good. My name is Kessels. I'm working for a company called Fairbanks. We are working very closely together with Red Hat for the Openstack deployments in the Netherlands and also for Ceph. And what I would like to talk to you about is we did some use cases with Ceph. So I would like to talk about what we did and what problems we ran into and what worked and what didn't work. But first of all, some thoughts about Ceph. So when you talk about when you think about Ceph, it's very important that you start with thinking about what do I expect from the storage, and not based on how much it is, but based on the performance that you want to get. So that's very important because that's the primary thing where you have to think about when you talk about Ceph. The size is not the problem. The performance is the problem, and there you have to think about before you start that. One thing is for sure: when you add nodes, the performance will increase. So if you have performance issues and you have money enough, put more nodes in and you will get a better performance. That's the easy way to go forward. If you have more similar nodes, of smaller nodes, smaller nodes will perform better. One use case what I will discuss later, we have 24 nodes with only one disk, and that's getting a really awesome performance, but yeah, you need to pay some money for all the hardware that you have to put in, but you get the performance what you expect from it. So, I take this one. So if you look at the storage node sizing, if you want to do block storage, then you should choose for small nodes. So you choose for nodes where you have maximum 24 hard disk in there. So don't go above that, because when you are using block storage, it will dramatically kill the performance. We did some testing with nodes who had more disks, like 36 disks. It worked, but you won't get the performance that you expect from it. So if you are doing object, then you can choose for large nodes, because most of the time when you're doing objects, the performance is not the primary thing that you want. Then it's more the size of the cluster that you want. If somebody has a question during the presentation, please shoot right away, because that's like it when it's a little bit open, and I'm not talking all the time. If you look at Ceph, we ran into Ceph because we did a lot of it Openstack. So for Openstack, Ceph is awesome to use. So if you're looking at the cloud and how you look at cloud, then Ceph is the backend storage for the Openstack platform that you want to choose, because the idea of scalability and efficiency is within Openstack the same as within Ceph, so that you have the possibilities to just add nodes if you need more capacity. And that is something what you can do in Openstack. But that's also something what you can do in Ceph. So that makes Ceph great, I think, and it works awesome with the combination with Openstack. And the last line what I mentioned was, yeah, if you need performance, just add more nodes, if it's possible, of course. But that really increases the performance. Of course, I heard the story about rebuilding performance, and what we notice is when you have two less nodes in your Ceph cluster, when you need to rebuild it, then it will dramatically decrease the performance. But if you have enough physical nodes in your Ceph cluster, like 20, then it's almost, then the rebuilding of, when there's a node failure, is not really impacting the performance, then that makes it much more robust.
Do you see that there's like a sweet spot? As far as, you know, like the amount of nodes, say in like a single failure domain versus like the impact of, say, losing a node?
Yeah, what we, correct me if I misunderstood your question, what we noticed, we did some rebuilding testing with 3 nodes, or with 4 nodes, and so we just pulled one out and looked what happened. Then the performance was really dramatically impacted by the rebuilding. But on the test with 12 nodes, the performance impact was a little bit, of course, but then the workloads were not, we just keep on running, and there was no real performance drawback on the VMs that we run on. So more nodes is much better for rebuilding, because I agree with you, when Ceph wants to rebuild as quickly as possible with everything he's got, that's very good, but bad for your performance.
Yeah. What is important to realize is that all nodes, as you say, the more you have, all nodes participate, all disks, your entire cluster participates in the rebuilding. So the more overhead you have, the better.
The more
or the more
you have
nodes.
for what can basically share the load.
And the CPU is also then very important, because if you have a single CPU node, the CPU power is then very important, that you don't have lack of it, because then extra CPU power will also increase dramatically the rebuilding process.
Okay.
Larger disk, 4 terabyte versus 1.
Yeah, well, we ran it on 900 gig SAS, and the nodes had two sockets, 10 cores, lots of CPU.
That should be good.
We didn't notice any CPU overhead at all. Well,
that's good.
I need a little bit.
Yeah, we run some testing with one processor on a 36 disk node, and then you have an issue with the CPU. This is something what we all, I think, already discussed. Good news is that Ceph can run on any hardware that you want, so that's good. On the other hand, it is also bad, because during the dinner I discussed with, sorry, I don't know what your name. Your name, Jeroen? Yeah, I discussed with Jeroen. He bought the last super duper hardware from Huawei, but he had some drawbacks on the Ceph performance, because he's not sure yet, but maybe it's the problem in the hardware. So the good news is you can use any hardware, but sometimes you run into these issues about drivers and firmware version of the hardware itself. And paying attention is to the hardware before you start is very important. What you sometimes see is that people want to start with Ceph, so they have some old hardware somewhere in the data center and they want to use it for a Ceph, and then they start testing with it, and okay, it works, but what you want to test is the Ceph performance. And I think that's sometimes very disappointing when people start to using it and they achieve to working it. But when it's then not giving you the performance that you expect, then it's a pity. So really think about that, because when you're doing proof of concept and you start asking, okay, what's the performance? They want to know what the performance is, because that's one of the primary things that you have to make sure that it works correctly when you are going to use it in production. And don't use RAID, because that's you shouldn't use that. So always use RAID 0 on one disk or just upon the disk. Both options are working pretty fine, but any other RAID configuration is not really working. Okay, now we have some questions until this point. Okay, good. And now I have some use cases that we did. This is one use case is on a retail company. It was used for production. It was used for a logistics application that ran on Oracle. And what we did is, it was not a big database. It was about I think 30 gigabytes. And we used Ceph for the backend storage for the Oracle databases, but we used it in combination with the cache here. And if you run the single application on the Ceph node, then it works pretty well, but you can get some latency issues when you are combining it with other applications or other virtual machines that you run on the same Ceph cluster. Because for them, latency was the primary thing, because the people are running into the warehouse and we did order picking, so every time they picked an item, then there was a transaction made in the Oracle database. So when the latency was bad, people started waiting in the warehouse, waiting on their response on the terminal. We changed that by we improved the performance by allocating one dedicated cache tier for only the Oracle application. So the Oracle application was using one dedicated cache tier for the Oracle database, and all the other applications were not using the cache tier but using the Ceph backend straight away. In that way, we could avoid that applications are influencing the Oracle database performance. Okay, we used Giant as the version, and we used Cisco hardware for it, and it was only pure block storage, so no object. And one of the primary things to achieve the performance was using the cache tier, but otherwise, without the cache tier, we couldn't get the performance that they required.
What did the cache tier consist of?
The cache tier was not so big, because the database was only about 40 gigabytes or something. So
SSDs?
Yeah, we used SSD, yeah. So we had one dedicated cache tier for it. So we had one cache tier with 6 SSDs, just primarily only for caching. And what we are going to do is we're gonna to duplicate or triple the cache tier, because it's of course a single point failure in this case, and we need to change that. But we managed to work. It works. It runs on Ref from Red Hat virtualization platform in combination with Ceph. It was not a really supported combination, but we managed to make it work. The other company was a telco company, the green one in the Netherlands. You already know, all know, of course. This is the example that I spoke with. They used 24 nodes with only one disk, and they got really good performance on it. And in this situation, you also could see when one node was failure or one disk was failure, there was hardly any impact on the performance of the Ceph cluster when something went wrong. So in this case, we could prove that how more nodes you use in the cluster, the better is your rebuilding performance. There were some issues with the kernel in combination with Ceph, so that was something what we need to what was solved, and it was based on IBM hardware, so it works fine. Another thing what they also did is they designed their own application, and they didn't use the S3 interface to talk to the Ceph cluster, but they used straight to Rails. And that's also very big performance improvements when you do that. When you use the S3 gateway, you will have one bottleneck because the traffic needs to go through there. If you use the Rails gateway straight on, and there's code available to use that, then you get a much better performance, because then the performance is given by all the nodes.
Do you remember the kernel issue, what version of the kernel it was, and describe the issue maybe?
I'm not exactly sure. I can ask for you, because I asked the engineer who was there, so if you want to know it, I can let you know.
Just curious.
Yeah, I was not there, so I'm not pretty sure what it was. And the last one was the broadcasting company. We did a POC of that. What they wanted to achieve was very interesting. All the data was processed in 24 hours. They wanted to process it within half an hour. So that was a very nice challenge for us to achieve that. The good thing about that was that they put the pressure on us to achieve that. So we need to really think about how we could do that. So that was the good part of it, because then you have to make sure that all the components in the Ceph cluster are working properly. So when one is not working good, then you won't achieve that. to be honest, we didn't achieve the half an hour, but we achieved it in 1 hour, so that was a very, very big performance gain for them. The problem that they had is what the application that they wanted to use was based on files sharing, so file systems, and that's one part of Ceph what is not really production ready yet. So based on the applications, they didn't choose for Ceph, they chose for cluster REST, but that was not based on the Ceph performance or based on the working of Ceph. That was based on the applications that they used, because most of the applications that they use are using file sharing, so that's something what is not supported in production for Ceph yet. It was a very nice POC because we had all opportunities to test everything that we wanted, so we get a lot of performance metric always, a lot of testing that we've done. And what we can see is sometimes you can have some, that's also what you were saying, you have some latency issues or performance issues, but if we look at how good Ceph is with handling the data, so how secure it is, not in one of the cases we lose any data. So the data consistency of Ceph is really, really good. But I think that's the strong point of Ceph. We tried a lot of things, but we never had the chance to really destroy it. Otherwise, then when you log in as a root user and you destroy the disk, okay, then you lose data. But in the scenarios that we tested, we didn't lose any data.
There was more hardware than only Supermicro.
Yeah, we only tested the Supermicro hardware, so that works really well. With the Supermicro hardware, we achieved that we could do the job in 1 hour. We also tested with Cisco C340 service, that are the storage nodes of Cisco. They get about the same performance, but the disadvantage of those systems was that they were not UCS supported. So then you buy a pretty expensive UCS server, but it was not supported within UCS. So then there was no advantage of using them. And there was a test with Dell hardware with an extra Dell disk disclosure behind the server. And that was, if you look at the performance of that system, it was less than the Supermicro hardware, because it always had to do with because there was an extra disclosure behind the server. So the hardware was, if you want to choose for Supermicro, it works. So it's a nice price, I think, that you pay for the hardware. Okay, I think that was it. Nicely on time, I think. Okay, more questions? Good, yeah?
For me, we were testing on old hardware. You say you will get a performance penalty. Can you indicate, like, that you use it to prove the concept, but it's not performing, therefore you discount it at a particular rate? Because I think most of us, what we are going to get is old hardware in their sector.
Yeah, I know. Yeah, but the point that I would like to make is be aware of that. And of course, the old hardware is great for testing, but be aware of that it will not give you the performance that you maybe expected. And that's the point that I would like to make. But of course, the old hardware, I think most of the Ceph tests are done on old hardware in the data center, I think. But it's great to test the features and great to test how it works, I think. Okay? Good. That was it. Thank you for your attention and maybe till next time. One thing I would like to mention, on the 1st of June, there is also a meetup for Openstack, and then it's based on SDN, software-defined networking. So if you are interested in that, find our meetup and we'll see you there maybe. Okay, thanks.